Yeah, there must be a loop because the states are not infinite.
Good morning, everybody. Welcome to Advent of Code Day 14. My name is Thomas and my guest today is Frank. Hello, Frank.
Hello, Thomas.
Frank, can you explain us the riddle for today?
Yeah, we got it here on the screen. So today, parabolic reflector dish. So what we have to do here is a simulation again. So what we get is a field of objects. There are some static objects, which are these crosses like rocks, and then there are these rolling objects, which are marked like a big O, so they can roll around, they can move. And now what we have to do for the first star is that we tilt this whole thing a bit to the north, and then everything rolls to the north as far as it can roll. So like here, this one would roll one line up and then stop in the top line. And also if it comes to a rock, it stops, of course. So, and then we get a formula how we can calculate a number from these positions. This is that the bottom line counts 1 point every rolling object, and second line every object counts 2 and 3 and so forth. And then if we count the weight of all rolling objects after we have tilted it to the north, then we get an answer for the first star.
Okay,
and this is
yeah.
To
recapitulate, every rock runs to the north, or runs above, like Tetris in reverse, and then we have to count every rock. And to count a rock, it's important in which line this rock is. Can you scroll a little bit down to the numbers? Yeah, here.
Yeah, here it is shown.
So, every rock in line 10 is 10 point per rock.
Yeah. So this is usually we store this data in a two-dimensional array in the program, and then the first line is at index 0, and here we have to well, take the length of the whole thing minus the index, and then we get this number here. So I implemented this this calculation thing here in a loop. So what it does, it iterates the lines and then the columns, and if it finds such a rolling object, it takes the length of the whole thing minus the current index of the line, and then that gives the answer. And this is pretty straightforward. We have to implement just somehow this tilt north. So this tilt to the north function, we can do it like this. I'm not sure if this is the nicest way, but it's doable. It's only like 12 lines of code. What it does, it simulates simply the thing. So it iterates call-wise, column 1, column 2, and so on, and then goes from top to bottom. And whenever it finds a rolling object, it actually moves it up until it cannot move it any further. So the times I find a dot here above such a thing, I actually move it, and then this is fast enough and works fine.
Yeah, straightforward.
Then we get it.
Nice.
So
what is a twist in part number 2?
So in part number 2, of course, we do not only tilt to the north, but instead we tilt in 4 directions: north, west, south, and east. And this is called one cycle. Tilting is in all 4 directions. And then the question is, after 1 billion cycles, what is the weight of the rolling objects?
Okay.
So 1 billion cycles is a lot, and 4 times tilting it will take maybe some hours or so. But if you think about it, this rolling thing, this will repeat sooner or later. So it looks like it will repeat. So we can try to find the loop size, how much steps or cycles it needs until the same configuration appears again. And then if we got this, and this is only some 100 or something like this, then it's much faster. So Yeah.
I got a question to understand. How do you decide in which direction do you roll, or for every direction 1 billion times? This is what I'm not
One
understand.
cycle is rolling it to the north, west, south, and east. So four
Okay.
tiltings, and
Also,
then 1 billion cycles.
also one time up, one time left, one time down, one time
Yeah.
right. Something like this.
So what we have to implement here is, of course, this tilting to the north. We have implemented in the first part, and now we need west, south, and east. So there's two possibilities basically. The one is that I choose just write it down for the other three directions. I copy these lines of code and change the indexing here so that it goes in the right direction. This is a bit clumsy to implement. And afterwards, Achim told me this, there's a better idea. We can simply rotate the whole picture and then always tilt to the north. This makes it a bit faster because you only have to rotate once. And we had this yesterday, so the code is directly available. You can copy it in and just do it. So this would have saved me some minutes. But okay, I did it in 4 directions. In the end, you end up with 4 methods which tilted in the 4 directions, and you do this simply and then check afterwards. So then again, this 1 billion thing is the complicated part here. How to get rid of this 1 billion, because we cannot move it or run it for 1 billion steps. It takes too much time. So what I did, I will demonstrate this here. It's a bit funny. So I just did like 200 steps, and then try to check here. Found a loop. Well, the first time I find a loop. For finding a loop, I create a hash map where I use this 2-dimensional arrays of chars as the key, and the value is the loop counter. And then if I find this picture again after some step, I here print in which step I did found it the first time. And now I will run this loop for 200 iterations, and then we will see that it comes out that it prints something, and what it prints can I use to optimize the code in the second step. So I need some seconds to compile.
Yeah, and to find a loop was part of some riddles before.
Yeah, it's pretty common that in these things are loops. So what the interesting thing here, so the first time a loop is found is after my 191st loop, and then it says in the 89th loop I had the same picture, and then I see in the next step it's always a distance from 102. This means after 102 cycles it repeats. So I can take my billion and modify it to a smaller value by mod 102. And then from this display, I came to the conclusion that I do this here. The number of steps I really have to go is 1 billion minus 89, because this was the first time I saw this. And then mod 102, because this is the loop size. And then I again have to add these 89, because these 89s come from the beginning. And if I run it for this number of steps, then I get the same result as if I would have run it for 1 billion steps. And then this gives the right thing. So I have to compile again and run again, and then it outputs the right thing.
Luckily, there was a loop.
Yeah, there must be a loop, because the states are not infinite. So the further, the sooner or later there will be a loop. The question is only how much the size is. And if you think about it and imagine it, the loop will be pretty small. So I was actually surprised that it's 100. I had thought it's like 5 or so. Yeah.
Okay, nice.
Whatever. So and then you get this answer, and it runs pretty quick also.
Cool. Frank, what was the hardest challenge today?
Yeah, typing these tilting functions or 4 directions, but as said before, this was not really necessary. this was took some time, yeah. Off by 1 errors and so on.
Yeah, I know. Okay, then big thank you, Frank, and we see us tomorrow.
See us tomorrow. Bye.